So today we're gonna talk about rotations. Well, in this video we're gonna talk about rotations, um, and rotations, just like reflections, is one of the trickier ones because we have these rules that we kind of need to follow. So the good thing is that because we're given these rules, all we need to do is try to figure out which one of them we're being asked for and then just follow it. So it says when a point AB is rotated counterclockwise about the origin, the following are true. So if you're rotating 90 degrees about the origin, you're going to take the point and basically switch X and Y. In this case, they're using A and B. And then you're going to take the opposite of B, which is basically just multiplying by -1. Then, if you're rotating 180 degrees, you're just going to multiply X and Y, or take the opposite of X and Y, or A and B. For a rotation of 270 degrees, you're going to first switch X and Y, or A and B, and then you're going to take the opposite of A. So an example of this would be this one that says list the coordinates of the figure after it's rotated about the origin. So it's going to say rotate 270 degrees about the origin. So the first thing that I would do is first list all the coordinates here. So J, K, L, and I'm going to say the coordinates of J are 1, 2, 3, 4. So 1, 4. The coordinates of K are 2, 3, 4, 5. So this is 5, 5. The coordinates of L are 7, 2. The coordinates of M are 2, 2. So because this is 270, my rule here states that what I would have to do is I would have to switch X and Y, and then I would have to take the opposite of A. So for my image, which would be J prime here, I would have to switch X and Y, which would be 4, 1, but I would have to take the opposite of A. So if A is positive here, it would be -1. So if I switched X and Y here, it would still be 5 and 5, but now it would have 5 comma -5. For L prime, I would have 2 comma -7. And then same thing for M. M is very similar to 5 comma 5. Again, guys, I've been struggling with my voice for like a week. 2 comma -2. So that's how you would apply those rules. Then on the homework, a lot of you guys had this question here. It says find the value of each variable. So as we know, rotations are isometries, which mean that isometries is a transformation that maintains size and shape. So when I complete this transformation, I keep the same size and I keep the same shape. So it doesn't matter a rotation is just a spin. So if you spin around, you're still the same you're still the same size and you're still the same shape. So all I did was take this original shape here, the blue, and I rotated it clockwise 110 degrees, and it ended up over here. So if I want to find the value of each variable, all I have to do is kind of match it up. So I would assume that this 12 here would match up with this 2s. So 2s is equal to 12, and s is equal to 6. And then I would use this information here to find the size that I need. So I would substitute that in here. So I would say 2 times 6 plus 3. So this would give me 12 plus 3, which is 15. So then 15 is equal to, this side here would match up with this one here. So 15 is equal to 3r, and r is equal to 5. And there's that one.